Hello everyone, my name is Will Wilson. I'm recording this video because I want to go through some of the material for University of Phoenix's CYB130 class. This is the first session where we're running the T-based course. This T-based course has a lot more students in it than our traditional classes. And we've also changed the material a bit so that the actual reading and practice is now something that's scored. I also noticed that with this version of the class, CYB130T has changed a few exercises around a little bit. So I want to go through some of these exercises and some of the material in the class and try to explain it. I've already seen in this class some people are searching for answers on the internet, and they're finding things that are close but not quite there. One thing that's good and bad at the same time is with these canned classes, a lot of people are doing the same exercises. That means the answers are out on the internet. That could help you if you're stuck, but it's also a problem if you just copy and paste it without understanding it. So I want to record these videos to help you understand the answer. Another issue is the material changes. When we update the material and you go to things like Course Hero, the material you'll find there is going to be slightly wrong. And if you understand the fundamentals, you can say, okay, what I found here answers this question, but the question was ever so slightly different, and now I can follow the logic and what the differences are, and I can use that. So I'm going to go ahead and share my screen and walk through some of the reading and practices and a couple of the exercises. All right, in theory, I should be sharing my screen that has the exercises right now. If not, I'll watch the video and find out that I'm not sharing the right screen. So many of you have already had some programming classes. The University of Phoenix, I'd say about a year and a half, 2 years ago, they introduced a class that is a good class to take before this class that uses a choral programming language. It's a little bit different, but it really focuses on teaching you the logic. If you understand the logic and you've taken this other class, it makes Python a lot easier. From my understanding, that class is not a prerequisite for this class, but it's a good idea to take before it. So for those who already have the fundamentals, this might be a little bit boring, but future videos might be more interesting. So for computer programming, we have the concept of input, processing, and output. The computer needs to get data from somewhere. It needs to get information from somewhere. And then it needs to do something with that data. And then after it does something with that data, it needs to put it somewhere. So when you get input, it's often from a keyboard, touch screen. Sometimes there's a file on a network somewhere that changes. Something that changes comes into the computer program. We can make a computer program that does nothing except processing, but it really isn't very useful. So if we have a computer program that only says calculate 2 plus 5, never change that and never tell anybody, doesn't do you much good. So one of the key things that a lot of students have trouble understanding with the initial exercises is the input process and the output process. In CYB130T, the input is provided by a script. In real programming, if you say I want input, then a real user is going to give it the input. In this case, we're going to ask for input. We're going to use a function that says I want input from the user, but there is no real user giving it input. It's all done on the back end by CYB130T. This causes some confusion because in a lot of exercises, the example in the exercise will give you numbers like 2 and 5, but then when you actually run the exercise for the test script, it'll come back and say 7 and 9 were the inputs. And a lot of students don't understand where the 7 and 9 came from. But as I get further into this, I'll show a few more examples of that. But the key is it's variable input. A variable in a programming language is pretty much like a variable in algebra. And for those who don't like algebra, we'll just say it's a lot like a box. If you were to take a box and put it on your table and you write X on that box, you could store something in the box. And you'll say, when somebody says, what's in X? You can say, well, this is what's in X. I open up the box that I labeled as X, and I see what's in it. So if I put 4 marbles in a box that I wrote X on, and another 5 marbles in a box that I wrote Y on, and then I say Z equals X plus Y, you're going to say, okay, how many marbles do I have in X? How many marbles do I have in Y? Let's add them together. And now I'm going to say Z, this new box, has that number of marbles in it. So that's the concept of variables. Think of a variable as a box and put something in it. As we progress through this class, we're going to talk about different data types. The first couple exercises, we mostly deal with numbers, and we also have some strings. But we don't need to worry too much about what is a data type quite yet. So scroll down a little bit in 2.1. It talks about a recipe. It compares a programming language to a recipe. It's, you do this, then you do this, then you do this. But you can further expand this example to almost everything in life. Every day you've got routines. And the routines you do, you can probably write a step-by-step thing saying, this is what I do every day. Some things vary in your day. They change. Not everything you do is precisely the same. But next week, we're going to talk about types and branching. Branching is how you deal with certain changes. I'll go more into this next week, but this is a lot of if-then. So within your day, you get up and say, oh, if the baby got up before me, then I need to do this. If I got up before the baby, then I'll do this. So if then else branches in Python and other programming languages are just like saying, if this happens, then do this. Otherwise, if this happens, do this. Otherwise, if this happens, do this. And if none of these happen, do this. Again, that's more of a next week topic, but I want to introduce it a little bit here. So this example isn't even in Python, so I don't want to discuss it too much, but it's showing you some basic examples in what we call kind of pseudocode. It's saying get next input, do this math, but this isn't Python, so some people just get confused by what is it doing. So I want to skip down a little bit to input and output. The basic way of having output in Python is print. Print is a function, so you need to use parentheses. If anyone sees any old Python code, Python did not used to require parentheses with print. When we changed this class from using Python 2 to Python 3, we had some problems because people were finding a lot of examples without the parenthesis. You'd get back an error saying, you don't have a parenthesis. Didn't you mean to have a parenthesis? But it still caused some confusion because a lot of examples were out there with Python 2 syntax without this parenthesis. Now, most of those examples are fading away. So here, print, and then quote, open quote, what do I want to print? Close quote. Everything in here, inside the quotes, is a string literal. Further down, we're going to start introducing variables. If you have a variable, you do not put the variable in quotes. That's another common issue I see a lot of students have. They get confused, and they'll do things like, so I'm bringing up my notepad right now. They'll say, my variable equals input. And they'll say print my variable. When you print my variable in quotes, it will literally write my var. It'll write exactly what you want it to write, or exactly what you wrote, not what you told it, what you're thinking. If you want it to give you the contents of the variable, you need to remove the quotes. Slightly later in these chapters, we're going to combine variables with string literals. And I'll get to that in a little bit. So in this example, it says, what statement prints welcome? So it has a couple different errors here. In the first one, there are no quotes at all. The second one, it mixes single quotes and double quotes. With Python, you can choose what type of quote you use, but it needs to be consistent. And so this third one, it's only got the single quote, so it's good. this one, it says, what pair of statements print output on the same line? In Python 3, they introduced something called end equals. By default, when you have a print statement, it's going to end the print statement with a new line, carriage return. It's going to say, okay, the line's over, I'm going to press return. When you do an end equals something, it overwrites this. So in this case, it's going to say end equals space, or correction, quote, space, close quote. So instead of ending with a new line, it ends with a space. So this could be kind of tricky. Actually, no, it's not, because this is missing its quotes. If this had quotes, I wouldn't be sure if the question wanted B or C. Because I'd say, okay, do you want a new line on the end of the second one or not? But because it's missing the quotes, we absolutely know it's this one. So this is saying, I want all in one line. I'm going to override the end line with a space. So I'm going to scroll down a bit to see if I can find one where I've had a couple student questions. So I did have a student question on this specific activity. Print a statement that prints the value of the variable num people. So a student said they tried everything. They didn't know what to do. They didn't send me a screenshot, but I'm going to make a guess they did something like this. This is a common thing when you're first starting to learn programming. You see everything with quotes and you put it in quotes. I hit check and it said no. And on that note, I hit check and it actually told me the expected answer. I don't know if that's what students see or if I just see it because I'm an instructor, but it tells you what the answer should be. It actually might have been a challenge activity that was similar to this. So I'll keep scrolling down a little bit. I mentioned the discussion board, the new line. New line has a special character called \n. Backslash in general is something special. If you actually want to print a backslash, you need to do it twice. Because whenever Python sees a backslash, it says whatever character comes next is going to mean something special. So if you did a \t, it would be tab. And a couple other examples that we'll hit throughout this class. So this is an example of breaking up a literal with a variable. This could be inflexible and have some issues because the comma is going to make a space. When you start doing formatted output, sometimes you'll want something that doesn't have a space, and this will cause an issue. So the answer of this is going to be UR space, the variable age equals 22, space years old. I'm going to do this wrong at first just to show an example of how picky Zybooks is. You notice here it wants a period. And it's going to say, I expected this period, and it's highlighted in yellow. It's because it expected something you didn't do. It's that picky. So now I'm good to go. Here we've got multiple variables, but it's the same concept. The pet name is Gerald, and then you put Gerald space the space dog is 22. That's a pretty old dog. If you don't want a space, there's some other things we can do. Somewhere in here, and I'll probably get to it as I'm scrolling through, we should talk about plus. Plus is concatenate if you're dealing with strings. That's just a fancy word for saying add some strings onto another string. The problem is when you're dealing with numbers, it wants to treat it as addition. So if I say print 3 plus 4, or 3 plus 3, it's going to say 6. If I say print the string 3 plus the string 3, it's going to say 33 because it's putting the letter 3 followed by the letter 3. But now if I do print the number 3 plus the letter 3 or the character 3, it's going to give me an error. It's going to say I can't do that. It says I can't handle mixing this. I don't know if I'm supposed to concatenate or add. So using plus in print is often dangerous. Sometimes we'll do a workaround and we'll say treat this like a string. And we'll say the string 43, which ends up being this value. The better solution is to use dot format, and we're going to hit dot format later in the chapter. So now we're talking about reading user input. The input statement gives a value from the keyboard. Notice how it says the keyboard, and this is what causes some confusion. When you're using CYB130T, it's not actually having you type from the keyboard. It's providing it for you. And we're going to hit that when I actually do an exercise. So how do I do input? The input needs to have a parentheses. Some people who've got some programming experience and they want to do things fancier, they'll say, well, the examples here aren't actually best practice programming when we first get started. So they'll say, I want to do something like num cars equals input of cars. If you put a string inside where it says input parenthesis, it'll prompt the user for that. The problem with that with CYBooks is if CYBooks doesn't want you to do that, it will grade it as wrong. Before we moved to CYBooks and I manually graded everyone's homework and I saw something like this, I'd say, okay, he wants to show that he knows a little bit more than when we're at the class, that's fine. He's still good. He understands the concept. So here it says complete a statement that reads the user entered string into a variable. So it's going to be my var equals input. That's it. And we're good to go. So now let's jump down to this one. Complete the code so the new variable is equal to entered number plus 5. This is jumping to a new concept. We're going to take your input and we're going to say make it into an integer. If what they entered wasn't a number at all, it'll give you an error. But for the first couple chapters, we're not going to worry about that. So now I want to say, what is this plus 5? So my variable has something that was supplied from the keyboard. What do I need to do plus 5? So I'll do my var plus 5. And we check it and I get it right. Now I strongly encourage you to actually understand all of these. Everything that you build up to, or all these exercises you build up doing, they basically teach you how to do the end of chapter exercises. There's a couple here and there that have some complicated logic, but for the most part, if you understand every one of these participation activities and you don't just get it wrong and then have them tell you the solution. Oh, here is show answer. Then you should be able to do the homework. All right. So here's a challenge activity. You can't quite see all your challenge activities, but if you followed all the ones before it, you should be good. So this says read 3 integers from user input without a prompt. So prompt is what I was saying is like, prompt. So this is, I'm going to prompt the user for something. I'm going to say the word prompt or give me a number. It doesn't want a prompt, so we're just going to say input. And I want to change it to an integer. And I want to do this 3 times. Notice we need to use 3 separate variables. If you use the same variable name 3 times, it's going to overwrite it. So now I've got 3 integers, and it says print the product of these. So product means multiplication. Sum would be addition. And it gives you an example. If it's 2, 3, and 5, the output would be 30, because 2 times 3 is 6, times 5 is 30. You would not believe how many times I've seen somebody do this. This is a common thing. People say, oh, 2, 3, 5, we're good to go. They often will get the input, and then they'll statically put 2, 3, 5. Another common thing is sometimes people will say my var equals 2, my var equals 3, my var equals 5. But we want it to be dynamic. So it should be and let's run it. So it tested it with 2 different inputs. If you statically set it to 2, 3, and 5, it'll give you the checkbox here. But then it pops in this 6, 4, 9. This is what I was talking about where people get confused when they say, where does this 6, 4, 9 come from? And I've seen students do things like this, where it'll say like, now var1 equals 6, var2 equals 4, var3 equals 9, if I could type. And then they try to do something like this, where then they just print it both times. And they're like, okay, I don't know where, they say they originally might have done 2, 3, 5. They might have originally done 2, 3, 5 and got the points for this. And then they didn't get the points for this. So they're like, oh, I'm just going to do it again. I'll print it again and see what happens. And here I didn't get any points because my output wasn't what it wanted. So errors are a fun thing to troubleshoot. At this point in the class, the errors are, I don't want to say straightforward, but they're less confusing than they'll be when we get into functions. Most of what you're going to see here is going to be indent issues and syntax issues. In this example, it's a syntax issue. You did a print and then spaced another print, but prints need to be on their own line. So it's coming up and saying, I don't understand why you have this print here. There's a lot of different reasons to have a syntax error. And I'd say for week 1 and 2, as you start hitting syntax errors, just post it to the discussion board and I can help point out what the syntax error is. A lot of this is just understanding what is a valid syntax. So what's a valid language for Python? Because writing print this, space print that, that's reasonable error to make when you're first learning and not knowing that they have to be on separate lines. And I can list off probably 1,000 different things that you can't do with Python that I know based on years of experience, but for those just reading this book, they might not have noticed the small issues. So if you get a syntax error and you can't figure out why, just shoot me a message, or better yet, put it on the thread for the homework help so everyone can see the solution. All right, I'm going to move down to the next section here. We're a few down. So this is another example that's very similar to some of the homework. It starts with a statically assigning hourly wage to 20. That doesn't change. We do that in a few exercises in this class where we've got some number that doesn't change. But most of the time, it's a variable read from the input. What this exercise wants you to do is acknowledge that there's a calculation error in the math. We have divided by 1, but there's 12 months in a year, so it should be divided by 12. And this hint tells you what's wrong. Change the 1 so the statement outputs monthly salary. So if you understand the equation, it's hourly wage, so how much you make an hour, times 40 hours a week, and I guess you don't work 2 weeks, so you only have 50 weeks in the year. And then you divide it by 12 because it's 12 months. This exercise wants you to think through the logic of how do I figure out what a monthly salary is? So figuring out the logic for a problem is one issue that takes a little bit of time getting used to. And I like to have people compare it to real life things. This is a pretty good real life example because people are commonly trying to figure out how much money do I make? What's my monthly salary if this is my hourly wage? So now let's go back and do a few of the homeworks. In my other video I made, I went through this example, but because I might use this one that I'm recording and post it on YouTube for future classes, I'll explain this in a little bit more detail. I already have the solution in here because I did it for my previous video, but this shows that the spaces need to be inside the quote. Some other issues I see students will sometimes have is they'll put spaces before the first print. This is going to give you an indent error. Python is very, very picky about indent. So it's going to say, I didn't expect this indent. Next week, when we start talking about branching, we're going to start seeing blocks with indentations. So in that section, you'll understand why to indent and when not to indent. But for now, you should say nothing should be indented. Another common error is put spaces here. When you have spaces here, they're just completely ignored. It's not an error, it's just not going to do anything. So in this case, my output doesn't have a space, and it's showing 2 spaces here. So it's saying this yellow blocks are saying I want 2 spaces, and you're not giving me any spaces. So the expected output is saying I want this, and it's not there. If you had any yellow here, it would say you showed me something I didn't want to see. But next I want to move to something that actually has some variables in it. All right. So they already have this print worked out for you. Print first name went to location to by a number, different types of plural noun. For any of you who play with Mad Libs, you're probably familiar with this concept where we say, give me a name, give me a location, give me a, pardon me, a whole number. So that's basically what we're doing here. So we're going to ask for 4 inputs. The inputs should match these variables because the book already gave you these inputs. So we're going to say first name equals input. And we're going to do this for all of them. Even though one of these says whole number, and you might think, oh, it's a whole number, I need to make it an integer. Because we're using Mad Libs, it doesn't matter. It's not doing any math with it. You can treat it like a string. It doesn't matter at all. It's not going to change it whether you make it an integer or a string. And I just made an error that I want to leave in here. When I copy and pasted, I accidentally copied a space in front of the plural noun. This goes to the indent error. So we can see here, it says indentation error, unexpected indent, input line 5. A lot of times students will say, it won't work, I can't figure out what's wrong. And I'll look at it and I'll say, okay, this is what the error you got means. In this case, it's pretty easy to see the indent error because this is one step over from everything else. Later in this class where we intentionally have some indents, sometimes you'll have an indent error, but it's more difficult to see because the lines are set up so they don't quite line up in a way that you can clearly see the indent. So this will work. So I'm in submit mode and I'm going to submit it for grading. While I'm doing that, I want to emphasize the submit for grading. There is no penalty for submitting for grading as many times as you want. When you mess with it in develop mode, I can't see what you're doing. If you submit it in submit mode, the instructor can see what you submitted. This makes it a lot easier for us to help you out. So I can go back and see every submission you've had and say, okay, I see what you did originally. I see the changes you made. I can see where you went wrong here, and I can steer you in the right direction. So I encourage students to use submit mode and just submit as often as they want. And when they get stuck, let me know and I'll look at it. The one disclaimer I have for that is don't submit it to the point where you get frustrated and you want to break your computer. If you keep changing it around and it's not working for you, more often than not, your first attempt was really close and I need to make a suggestion for 1 or 2 changes and it'll fix your script. If you start getting frustrated and spending an hour making changes, you probably should step away, take a break, move on to the next exercise, post it in the discussion board, or send me an email and I can give you some help. So this worked, I got all the points. In this exercise, we also get the common thing, common issue that I've mentioned, where people will assign it statically, Chipotle, if I could spell, 12, and cars. So again, when we do it this way, the first one was a sample. So we got, from this example, it was Eric, Chipotle, 12, and cars. But then I had two other inputs. So I'm going to submit this, and I should get only the points for the Chipotle one. So I got the points for this, but then when the grading script gave you Tiffany, Disneyland 3, and radios, we're still Eric, Chipotle, 12, and cars. So we need to use the variables. So when I said use the inputs, that's what everything should be. In these examples, you should never be statically setting anything from the example. You should always be using an input. I'll try to stay ahead of the problem on the couple homework problems where it really, really wants you to statically assign something. But when it does that, it's explicit. All right, so this should be good now. After this, we shift tunes quite a bit, and we start going into math. When we do the math, there's two different types of division. Addition and subtraction are very straightforward. But addition and subtraction is straightforward. Division can cause a problem. Python has floating point division, and it has floored division. So this floored division says, I only want the integer portion back. So when you divide something, it's going to toss the remainder. So 5 divided by 10 is 0, remainder 5, and it throws away this remainder. So this floor means throw away the remainder. Don't round up, just always round down to the nearest integer. And it throws away all this remainder. We have a few exercises that want you to do that. One of them I think is not as clear as it could be, but when you look at the sample output, you can see that's what they want. And they do give you a note, saying a hint to tell you to do that. So here, 12 divided by 4. What is 12 divided by 4? Well, this is wants floating point syntax. It's going to be 3.0. If you look at examples with Python 2, in Python 2, 12 divided by 4, it would actually keep it as integers, and the answer would have been 3. Python 3 behavior changed. So sometimes you can find conflicting information about this. So here, 5 divided by 10, well, that's floating point, so it's 0.5. In general, if there's a 0, if there's nothing before the decimal point, it'll usually want you to put a 0. So here, notice how if I didn't put the 0 in front of it, it said it was wrong. Technically, these are both the same thing, but Zybooks is picky. And I know it wants 0 before it just because I've been using Zybooks for about 2 years. Now it's going to be 5.0 divided by 2 using the floor. So 5 divided by 2 is 2.5. So the floor is going to be 2. And hold on. Did I mess something up? I don't think, I'm not even sure, I'm not sure if this is right. Hold on. Okay, it is right. I apologize. It's a floor, but I was thinking that it would make it an integer. And now this is a divide by 0. You have a homework example on divide by 0. Anything divided by 0 is undefined. So 100 divided by 0, I don't know what it wants us to put in this example. It's going to be an error. All right, that was the answer. All right, now modulus. Modulo is how you get the remainder. It's just a fancy term for remainder. When you do 24 modulus mod 10, you're saying I want to do 24 divided by 10. 24 divided by 10 is going to be 2 remainder 4. We don't care about the 2. All we care about is the remainder. So the answer is 4. So you don't need to get too wrapped around with this fancy term. Just mean all I want to know is a remainder. You might say, why do I care about this? Why do I want to know this? This is going to come in handy in at least 3 exercises we're going to do. One exercise is detect if something's even or odd. If you divide something by 2 and there is no remainder, it's even. If you divide something by 2 and there's a remainder of 1, it's odd. So we use this to detect even or odd. We also have a leap year exercise. We'll use this in a leap year exercise and say, okay, if you divide it by 4, if there's no remainder, it's a leap year. Otherwise, it's not a leap year, minus some extra conditions that we'll show you. And there's one other exercise where we're dealing with money. And you might say, how many quarters are there? How many dimes? And we'll use some modulo math for that. I think that that's in week 2 and it pops up again in week 4, assuming that it didn't get removed in this iteration of the class. So we'll cover that more later. Oh, and right here, it has even another example of minutes. So how many hours are there? Well, the number of hours is the floor of the total number of minutes divided by 60. And then how many minutes are there? Well, now we only care about the minutes. So the minutes is the remainder of this division. So this is a perfect example. All right. This has some cool information in it, but we don't really need to worry about this too much until we get to the functions section. So I'll cover this more in the functions section where we're talking about the if name equals main. So next thing I want to talk about a little bit is the math function or library. Import is a way to import a library or a module. Python has a lot of built-in functionality, but sometimes we need to add something else. And when we want to add something else, we need to import it. You can write your own libraries and then import them and reuse them in different things. And there's also things that are built into libraries that come with Python that you can import as you need them. A common mathematical operator is square root. If we want to use square root, we need to import math and then run square root on it. Some of our homework assignments will use this. So this imports the function, or the library, and then we'll call the function. When we're dealing with libraries and classes, we'll often actually call this a method. So you might find me interchangeably using a method and function. They actually have slightly different meanings when you get technical, but for our purposes, we can just use them interchangeably. So another thing I want to point out, other than square root, is power. One of your homework assignments is going to use power. This is going to say math.power is 2 to the power of 10. So let's say 2 times 2 times 2 times 2, 10 times. If you need to square something, you'd say math.power is something, whatever your variable is, comma 2. And this is all the functions there are. Actually, this isn't all of them, but this is enough to get you started. And this is more than we are going to need for any of our exercises. We're going to use ceiling. We're going to use power. We're going to use floor. We're going to use absolute value. In general, we're not going to use, and we'll use square root. We're not going to use most of these other things. We're not really going to do any trig in this class. We used to have some trig functions in the homework, but we got rid of them because there was a lot of complaints. So if you go through these, this will kind of help you understand how to decode what the answer is. So math.ceiling. So this isn't a rounding function. This is going to the next number. Ceiling goes up. So that's going to be 3. Floor, it's going to go down. So now it's starting to try to get trickier. It's saying what's the floor of 4.5? So the floor of 4.5 is 4. And then to the power, so now we're going to say the floor in here, now to the power of 2. So 4 to the power of 2 should be 4 squared, which is 16. So we're going to start going to the things where you've got a function call inside of a function call. We do this extremely commonly, and you have one homework assignment where we do it. Now this one, we're going to do the square root of the ceiling of z. So z is 15.75. That means the ceiling is 16. The square root of 16 is 4. And I understand that not everyone likes math, and so this might just make you grumpy even having to do it, but working through this helps you understand what the function does. And the good news is when you actually do your exercises, you don't need to actually figure this out per se. You just need Python to do it for you. If I didn't want to figure this out myself, I could go into my Python interpreter and do this, and I forgot to import math. And I'm glad I made this error because this is an error a lot of you might make. If you don't import math and you try to use things that are in math, it's going to say, I don't know what math is. Depending on the version of Python you're running, it might say math is not defined or it hasn't been imported. But this lets you know, hey, I can't find this. I don't know what to do. So I had one student question on this. We've got the 4 variables we read in, and we need to figure out the point distance. And this was the common error that I keep mentioning, that the student changed it and said, okay, well, I see this 1, 2, 1, 5. Now what do I do? Actually, I got this question twice. So one person swapped it out and in the equation just put the literal numbers. And then it didn't change it as needed. Another student did something that actually makes a lot of sense, but was a syntax error. And this is one of the things that I say you have to understand that's not the syntax. So I need to know distance equals. You should only have one equal sign. I've seen some examples where people are doing something and they have 2 equal signs because something they were reading, some example was showing this equal, so they brought over an extra equal. That's a common syntax error I see. So now we need square root of. So I'm going to say this math dot square root of what? So I've got x2 minus x1. And now I want this actually to the power of 2, right? So the student, one student did something where they had something like this, and then they said exponent. When you're reading the material, you see the exponent. You're like, oh, I want exponent of 2. But that's not actually how the function works on Python. For Python, we're going to take power, we're going to use the power function. And so now I'm going to say I want to take x2 minus x1 to the power of 2. Alternatively, you could do x2 minus x1 times x2 minus x1. So that would be like saying this, y2 minus y1, and let's just do it again. In some cases, this is just as easy. If you only had 2 numbers, sure, why not? So now I'm taking the power of this plus, I had a typo. I'm actually going to leave the typo in just to show you what the typo will look like. So let's run it and see what error I get. Square root takes exactly 1 argument, 2 given. I accidentally put a comma here. The problem with the comma is now it's saying, okay, I'm sending 2 different things to square root. Square root doesn't know how to do a square root if you pass it 2 variables. This should have been plus. So now this is calculating the Euclidean distance between 2 things. I run it, and something's wrong. And I'm sure y'all watching the video, most of you are looking at this and say, that's so obvious. I see what's wrong. Why don't you get this? So it's getting the inputs. Oh, wow. Really simple error, and this is actually another common student error. I called it distance. I thought that I see the word distance here, and I said distance. The variable it uses in the print is point distance. It said point distance equals 0. If it didn't already have that, and let me change this. All right. If it didn't have this, I'd get an error because it would be trying to print point distance and be undefined. So it should be point dist. So it was giving me 0 because I was changing the wrong variable. Now that I'm changing the right variable, we're good. And notice how here, in one case, I did the power. In one case, I just multiplied them times each other because a square is just multiplying something by itself. So tree height, this is the same concept. Now what is my tree height going to be? So my tree height is going to be oh wow, so this is actually using tangent. All right, I actually don't like this one too much because it's giving you, it wants you to get the tree height based on knowing the tangent of the angle elevation and the shadow length. So we need to change this equation around a little bit. The algebra class is not a prerequisite of this class unless they've changed it recently. In the final exercises, we used to have things like this, and they were taken out because we decided it was a little more advanced than we needed to go into. So I want the tree height. So the tree height is going to be the tangent of the angle elevation times the shadow length. Because with algebra, if I want to change the equation, I'll multiply shadow length on each side, and now that's going to leave tree height by itself. So tree height is going to be the tangent of angle elevation. So I'm using this variable. I'm not going to type it in. I'm not going to like statically set 0.4. So it's math.tangent of the angle of elevation times the shadow length. And again, I'm taking times because I need to fix this so that tree height is on one side of the equation by itself. So now shadow length. One common issue is they'll copy out the variable as they see here, but they really should be using the variable as they see it here. So let's run it, and it doesn't like something I did. It says angle eval is not defined. Because it's not eval, it's LF, of course. So when you see things like this of it's not defined, Python dynamically defines variables. Some programming languages, you have to explicitly say, I'm using this variable and this data type. With Python, you just use something. If you give something a value, it's going to say, okay, this is this type of variable. And again, we're going to hit data types more later. I don't want to get into too much yet. When you're printing something or sending something to a function and it hasn't been assigned a value, it's going to say, I don't know what to do with that. It's not defined. So when you make typos in variable names, you'll get this error. A typo can be something like where I messed up the L and the V. You could capitalize, you can put an extra underscore, you can miss an underscore. Any minor difference is not the same variable. It needs to be exactly the same down to the capitalizations. So now we're good to go. Yeah, it looks like we've reduced our homework since the last time I did this. So I'm going to do the calories burned. And I did this in the last video I recorded just to show some variations. I'm going to wipe what I did and start over. So it starts actually load default template. All right. So I'm going to use the load default template button. Load default template should wipe over everything you did and say start over. In the previous version of this class, we had it having men's calories and women's calories, and it gave you a different equation. So if you go to the CHEG website or Course Hero and you look up this exercise, you're good chance you're going to find the old version. And if you copy and paste in the old version and you, as you try to work through it and try to understand it, you're going to see some issues. So this tells you the equation, and now we need to use this equation to figure out what to do. So we have 4 inputs. Inputs are age, weight, heart rate, and time. So age is input, and you have to make sure we have these in order. If they're not in order, it's going to cause you issues. So we have age, and this actually recommends variables. So it says years. So let's do years. At this point, it doesn't matter if you call it some other variable. It's up to you. When we get to the function section, the variable names should match what it tells you to for a good reason that we'll explain later. And so now the next variable, let's call it pounds. And we're going to say that equals input. I have an error right here that I'm going to fix in a minute. I want to show you this error, and then after I have the error, I'll fix it. So BPS, we can't have spaces, so I'm going to call it BPS because beat space per space minute is going to be a problem. Same thing as if you use heart space rate. You can't have a space in your variable name. And then minutes. Now I brought these all in as text, and now I'm going to try to do math on them. It's not going to like that. So calories equals, I'm just going to copy and paste this. And now I'm going to change it out to my variable. And I'm going to leave a couple errors in here. Again, I'm intentionally leaving errors because I want to show you what the error looks like so you can understand how to fix it. All right, so now I've written something where I've got all the variables in, and I have at least 2 errors. I've got 2 errors on purpose. Now we want to print it. When you see hints like this, they're there for a reason. In this case, it's pretty much exactly the precise answer. Sometimes these hints are not the exact answer, but they get you close. This is a formatted print statement. I have dot format, and then after dot format, I'm passing in the variables. So you can have several different variables that I'm passing in. And then it replaces these tokens. So open bracket, colon, period 2F, close bracket. That says take the variable, and I want it to be a number up to 2 decimal places. There's a lot of different formatting things you can do here. And if you go to W3 Schools or the official Python documentation, you can see a list of all of them. And it has some of the book also. But in almost every single case in this homework assignment, when it wants a formatted print, it almost always shows you the format. It doesn't always show you the precise exact answer, but sometimes it'll have something very, very close where you just need to slightly change the text. But it's going to have the token you need and the variables you need. So now I'm going to do this, and let's go to submit mode and submit it for grading. So it complained about this invalid syntax, and it's pointing at the X. The reason is X is not multiplication in Python. It's the letter X. The asterisk key is multiplication. So if you just grab this and paste it, you get that error. So now let's move on to my next error. So my next error is, okay, it's complaining about this. My best guess is that this is not a minus, it's a longer dash. So I did a minus next to it, and now you might be able to see, let's zoom in. These are not the same thing. See, this is a much shorter character than this. So one is a longer dash. This could be a really frustrating one if you didn't know to look for that, because you say, what do you mean this is an invalid character? I got a minus right here. What's wrong with my minus? Sorry, I was talking on mute for a while. I'm not sure how long I was talking on mute. I might end up having to record this again. So I was showing a typo that I fixed and showing that with a typo, it said it was looking for a function name, but it wasn't defined. And so I had to correct it so it was a properly defined one. And then I showed an example of putting an extra period in. And with the extra period, it has this yellow box saying, you're showing me something that I don't want to see. This is what I should see. So this yellow box in your output is something it doesn't expect to see. When you have something that's just completely messed up, it might show pieces where it lines up and it'll have weird yellow boxes on both sides. So let's do another one where it should have slightly different yellow boxes. So in this case, it's not expecting to see a lowercase c, it's expecting to see an uppercase C. So it's saying, you gave me this, but I'm expecting to see this. So in this case, it's showing the difference. And with that, I think I'm going to close this video off. If you have any questions and you're in my class and this isn't just a random YouTube video you found, go ahead and shoot me a message. I can record more videos with specific questions you have. I'm going to be recording a week 2 video, probably towards the beginning of week 2. I just wanted to get this one out to show some common errors before week 1 ended. I think once everyone gets the fundamentals of week 1, it gets a lot easier. In week 2, we'll introduce a couple different data types, and we'll show things that are a little more in depth than just strings and numbers, and we'll start worrying about the branching. The branching is just what I was explaining of if then else. You deal with if then else all the time in everyday life. So once you can equate this to something you do every day, the concept should be fairly simple for you. And we just have to learn the syntax, and you have to learn when to indent and when not to indent. So with that, I'm going to turn off my recording, and I'll see you in class.